Welcome to This Explainer. Today, we're taking a deep dive into the hidden mechanics of your cardiovascular system. Have you ever wondered what's actually happening inside your arteries as the years tick by? Well, we're going to shrink down and explore the microscopic world of our blood vessels. We want to understand exactly how they age, and more importantly, how we can protect them. So, let's just dive right into the ultimate question of longevity. Look, we all know cardiovascular disease is a massive issue as we get older, right? But the underlying cellular reasons, they're incredibly specific. We're going to see if science actually holds the key to reversing the clock on our arteries by zooming in on the very molecules that keep our blood flowing smoothly.
Here's our roadmap for today's explainer. We're going to cover the threat of vascular aging, meet a little hero molecule called nitric oxide, see what happens when good enzymes go bad, uncover the dangerous trap of inflammaging, and finally, check out the therapies that can actually rescue our vessels.
All right, part 1, the threat of vascular aging, specifically stiffening and dysfunction.
Here's the crucial takeaway. Vascular aging isn't just, time passing. It's a literal physical breakdown. As we age, the inner lining of our blood vessels, that's the endothelium, and the smooth muscle cells go through some really intense remodeling. Our vessels literally lose their flexibility. They get stiff, calcified, and way more prone to injury. It's this exact endothelial dysfunction that's the common denominator for all those things we worry about later in life. Hypertension, atherosclerosis, heart failure, the whole shebang.
Moving right along to part 2, nitric oxide, our body's protective hero molecule.
To really grasp how nitric oxide is made, I want you to think of nitric oxide synthases, or NOS for short, as 3 distinct little factories inside your body. When we're young, each factory has a super specific job. First up, eNOS, the endothelial factory. Think of this one as your clean energy plant. It pumps out the baseline nitric oxide that gently relaxes your vessels and keeps blood clots at bay. Then there's iNOS. This is the heavy-duty factory. It's usually asleep, but it wakes up when there's inflammation or an infection, and it just churns out massive amounts of nitric oxide as a defense mechanism. And finally, NNS. That's the neuronal factory, which modulates the tone of your microvessels.
Just to give you an idea of how absolutely vital this molecule is, check out this data. When researchers studied mice engineered to lack all 3 of these NOS factories, the results were honestly staggering. They saw an 80% drop in the survival rate, mostly from spontaneous heart attacks. So what does this tell us? Nitric oxide isn't just some background helper. It is literally a lifesaver. It's a fundamental player in cardiovascular health and longevity.
Which brings us to part 3, when good enzymes go bad, or the aging crisis. Take a look at this mechanical failure. A healthy eNOS factory uses an amino acid called L-arginine and a really vital cofactor called BH4 to produce our good friend nitric oxide. In science terms, we call this a coupled state. But as we age, that BH4 gets depleted, and without it, the eNOS enzyme literally uncouples. So instead of making healthy nitric oxide, this broken factory starts spewing out toxic superoxide radicals. Basically, the exact enzyme meant to protect your blood vessels turns into a radical-generating polluter. Wild, right?
And you can really see the macroscopic impacts of this breakdown here on the right side in red. In aged endothelial cells, those good eNOS factories are completely uncoupled. Nitric oxide plummets, while harmful oxidants like superoxide just spike. And to make matters even worse, that heavy-duty iNOS factory gets inappropriately flipped on by vascular inflammation, so it produces massive amounts of NO that react directly with the superoxide. The result? A highly destructive molecule called peroxynitrite that seriously damages your blood vessel walls.
Now for part 4. This is the trap of inflammaging, and trust me, it's a vicious cycle. Think of inflammaging as this latent but incredibly dangerous condition. It means having high circulating levels of pro-inflammatory markers, but it operates totally under the radar, without visible symptoms. Basically, it's a self-sustaining loop. The oxidative stress of aging causes chronic inflammation, and then that inflammation turns around and heavily accelerates your cellular aging. It literally drains your body's biological reserves over time.
Let's break down exactly how this vicious cycle traps our cells in an endless loop. Step 1, the eNOS factory uncouples because of age, kicking off oxidative stress by producing superoxide. Step 2, that oxidative stress acts like a blaring fire alarm, triggering the heavy-duty iNOS factory to overproduce NO. Step 3, all that extra NO crashes into the superoxide, creating that highly toxic peroxynitrite we just talked about. And finally, Step 4,
The peroxynitrite damages lipids, proteins, and even the DNA in your vessels, which, you guessed it, fuels even more inflammation. The cycle just repeats, and vascular stiffness sets in for good.
But it's not all doom and gloom. Part 5, therapies to rescue our vessels and rebuild those factories.
Fortunately, we actually have some powerful therapeutic allies. This table breaks down how specific, well-known therapies can directly intervene to fix our factories and clean up that cellular pollution. Take statins, for example. We know they lower cholesterol, but they actually also help recouple the eNOS factory by boosting that missing BH4 cofactor. Folic acid does something really similar, chemically stabilizing BH4 to get nitric oxide production back on track. Hormones like estrogen can actually boost eNOS activation, and natural compounds, like resveratrol and diosmin, they have incredibly powerful effects on both inflammation and oxidative stress.
Looking down at the cellular level, we can trace exactly where these therapies swoop in to repair the broken systems. Notice how statins and resveratrol work all the way down at the transcriptional level inside the nucleus, literally increasing the stability of the eNOS mRNA. Folic acid steps in right at the enzyme level to force that recoupling. By targeting the exact molecular breakdowns that happen as we age, these interventions actively shift the cellular environment away from toxic oxidative stress right back toward healthy nitric oxide generation.
I want to really highlight two incredible natural compounds from the research. First, diosmin. This is a flavonoid derived from citrus. Studies in aged rats showed that chronic supplementation partially restored their endothelial function. It did this by slashing oxidative stress, both mitochondrial and from NADPH oxidase, and dropping damage markers like malondialdehyde. Then we have resveratrol, that famous polyphenol found in red grapes. It acts at the genetic level to directly activate the eNOS promoter gene, block inflammatory pathways like NF-kappa B, and completely reverse eNOS uncoupling. I mean, it is just fascinating that compounds from everyday citrus and red grapes can operate on a genetic level to fight inflammation.
As we wrap up this explainer, I want to leave you with a thought. We've seen today that vascular aging isn't just a passive decline. It's an active loss of our protective nitric oxide factories, pulling us into the trap of inflammation. But the science is clear. Those microscopic factories keeping our vessels young can absolutely be supported and repaired. Knowing how critical nitric oxide is to your overall longevity, what choices will you make today to protect your hero molecule? Thanks so much for joining me on this deep dive, and I'll see you next time.